So we're going to use FOIL on this, on question 9. So we're going to do x times x, the first ones. The outer ones are nm, inner ones m, what am I doing, sorry. Outer ones nx, inner ones mx, and last ones mn. Now, the two middle terms here, I will just point out that we could factorise that further on. We don't need to for this question, but it is going to be used later on. So we've got nx and mx. So really we've got n plus m, and the common factor is x. We will be using that in a second. So on this question, it's asking you to express these terms here, q and r, in terms of m and n. So q is the number in front of x in a quadratic. So the number in front of x, as I said here, as when I factorised, was n plus m. So that is that bit there. The r is the number at the end of the quadratic, the number that doesn't involve r, x, should I say. It's just a number on its own. So that's mn. So that's the bit where we do m times n. Now, question 9c is about, ask you to understand what happens when you multiply and add odd and even numbers. R is an odd integer. Now, for this to be odd, if you think about it, to get an odd, you can't do an odd times an even. So, for instance, 3 times 2 would be 6, which would be an even. And the reason it's even is because it's got a factor of 2 in it. If this has a factor of 2, then this has to have a factor of 2. So we can't have any evens in a multiplication in order to give us an odd. The only way that you can get away with that, to give you an odd answer, is to do an odd times an odd. So that's my explanation of that. I'll just hide that for now. That means to get an odd value of r, m and n both need to be odd. And I'll just explain. Odd times odd equals odd. Right. Now, if these two numbers are odd, then an odd plus an odd is an even. The two odd bits go together to make an even. So, for instance, 3 plus 7 makes 10. So I'll just get rid of that. I don't really need that. But I will say that odd plus odd equals even. So Q must be even.